Alright, so we're going to go ahead and start the next section. So I'm going to do the simplifying each expression, and these are the ones I'm going to do. So we have 14, 17, 20, 21, and 22. Those are the ones I'm going to work out with y'all. So let's go ahead and start with number 14. Now, I know a lot of y'all freak out when you're simplifying because in class they're always telling me, I just don't know when to stop. And I think for a lot of these problems there's different ways that you can approach them. But with a lot of practice, you'll start realizing like, okay, this is where it's finally simplified. I can't go any further. Can I break things down? Alright, so the first thing I'm going to do is for number 14. I have 512 x to the 9th. Now you could do your staggering exponents with the face, but I don't like having this negative exponent, so I'm going to bring this down, right? So I'm going to put it over 1 to make it positive. Now everything on the inside stays the same when you bring it down. The only thing that changes, guys, is the exponent. So the exponent now becomes positive. So now I am going to rewrite this in radical form, which is where I draw the little house. You are the inside guys, right? So you are 512 x to the 9th, and then you have the cube root on the outside. Now, what is the cube root of 512? This is where you can look at your chart. So if you look at your chart, the cube root of 512 is 8. And I still have x. Now your friend is the 9, right? Writing it down in exponential form. And then your not-so-friend, your jerk face, the guy that you kicked to the outside of the house, is your 3. So now I am checking to see if I can reduce that, and I can. So 9 divided by 3 is 3, and then that is your final answer. I can't break down x to the 3rd, and then there's no point in rewriting 8. So you're good. Alright, so let's get to now number 17. This is when we have a lot of square roots. It looks a little scary. So I have the square root of the cube root of 27x to the 9th, y to the 6th. So I always tell my kids, kind of like when we did the Fogg and Gogg stuff, the composition of functions, start with whatever's on the inside. So I have 27x to the 9th, y to the 6th. And I'm going to put that in big old parentheses right here. And so this, right, is raised to what power? What's your first radical close to it? 3. Remember, this is all to the 1/3 power, right? Because if 3 is on the outside, and this is all raised to the first. Alright, so now I'm going to draw another parentheses. I'm going to draw a bigger parentheses. And now what's your last radical that we have here? There's no number, so I assume that's a 2, so that's to the 1/2 power. Alright, I'm going to see if I can break down 27, see if I can write that smaller. I know that that's 3 cubed, so I'm going to rewrite this as 3 cubed, x to the 9th, y to the 6th. I just like simplifying everything pretty small. Just helps my numbers a little bit easier. So all I did was rewrote the 27 as 3 cubed. Alright, now I have the staggering exponents. Y'all see that? So I have like a bunch of little faces with the eyes. So I'm going to multiply. So I have, first let's do, there's 3 different terms. I have the 3, the x, and the y. So let's do the 3 term. So I have 3 over 1, right? And when you multiply, and when we have the staggering exponents, you multiply. So times 1/3 times 1/2. So you end up getting 3 over 6, because 3 times 1 times 1 is 3. 1 times 3 times 2 is 6, which is 3 to the 1/2 power. Now let's do the x. You have x to the 9th. So it's 9 over 1 times 1/3 times 1/2 So you get x to the 9/6. And then if you reduce each by 3, 3 goes into 9 twice. 3 goes into 9 3 times, sorry. 3 goes into 6 twice, so it's x to the 3/2 power. And then the last one is the y. So we have y to the 6/1 times 1/3 times 1/2. So you have y to the 6/3 times 2 is 6. And then 6/6 is just 1. So it's just y to the 1st power. Alright, so for this one, you have 3 to the 1/2, right? X to the 3/2, and then y to the 1st power. I want to write this in radical form. So these guys both have fractions, right? They share a common like jerk face, so I tell my kids when you kick them out of the house. This guy doesn't, so he's going to come to the outside. So you have y. And then on the inside you have 3 in the x. The friend for 3 is 1, the friend for x is 3, and then you have 2, like that. Now, I always want to check this number right here. Is this smaller than the exponents on the inside? Always check, because you don't want that. So like here, 2 is bigger than 1, so we're good. Sorry guys, my computer just glitched. So let me kind of go back. So I always check if this number, if it's smaller than the exponents on the inside. That's what I'm looking for. So see, this is a 1. 2 is bigger than 1, so we're good. But is 2 bigger than 3? No, it's smaller. So that means I need to simplify the x's. So I can rewrite x cubed as x times x times x, and then 3 to the 1st power is just 3. So since it's square root on the outside, I can get a pair of x's and bring them out. So this is going to become xy, the square root of 3x. And that's all that's left. That's my final answer. That one was a little tricky. Alright, let's go to the next one. Number 20. So I have negative 27 x to the 6th over 8w cubed to the 2/3 power. Alright, so for this one, I am going to distribute my 2/3 to each term. So it's going to look like this. Negative 27 to the 2/3 times x to the 6th to the 2/3 over 8 to the 2/3 times w cubed to the 2/3, just like that. Alright, so I want to see if I can reduce any of my big numbers. So I know 27, I can rewrite 27, guys, as 3 cubed. It's going to look just like this. X to the 6, I can't do much there. And then 8, if you guys look at your chart or just know, how can I rewrite 8? I can write that as 2 cubed. 2/3 is still there. And for the W, we're still good. So now what I'm going to do is I have my staggering exponents. So I tell my kids, anytime you have your little staggering exponents, it looks like a face, right? These are the eyes. These are the faces. It's the nose. That's the mouth. You multiply the eyes like this. You multiply these numbers. So I have negative 3, right? And it's 3 over 1 times 2/3. So you get negative 3 to the 6/3, right? And then so this would be negative 3 squared, which is 9. that negative is in parentheses the whole time because that's what we had over here. So just make sure y'all keep that guy in parentheses. So now let's do the x to the 6. So I have x to the 6 over 1 times 2/3. You get x to the 12/3. So you get x to the 4th. Now I have 2 to the 3rd, so 3 over 1, times 2/3. We get 2 to the 3 times 2 is 6. 6/3, so that's squared. And 2 squared is 4. And then the last one I have w, so w 3 over 1 times 2/3. You get w to the 6/3. 3 times 2 is 6. 1 times 3 is 3. So you get w squared. Now I'm just going to rewrite. So this guy was on the top. Put this down. So we have 9 x to the 4th. Those guys are on the numerator. And then the other guys are on the denominator. So you have 4w squared. And that is our final answer. Like I said, there are different ways to do these problems, guys. You could have done it a different method. As long as you get the right answer in the end and you're using the right exponential rules, you are golden. You're good. So this is how it makes sense in my head. Alright, let's do 21. So I'm going to do that one over here. So I have 32 to the 243, or 32 over 243. It's negative 2/5. Now, anytime I have a fraction raised to a negative number, right, or negative exponent, I am going to, so anytime you have a fraction raised to a negative exponent, how I simplify is I'm going to flip the inside fraction. So 32 over 243, the signs all stay the same, you just flip it. It now comes 243 over 32. And then 2/5 now comes positive, so it becomes positive 2/5. Awesome. So I'm going to rewrite this in radical form. Right, you have 243 over 32. Your friend, guys, is the 2. And then the guy that gets kicked to the outside is the 5. Now I'm going to break this up top and bottom. So you get the 5th root of 243 to the 3rd. Sorry, not 3rd squared. Wrote that wrong. And then the 5th root of 32 squared. So I broke it up top and bottom. And the 2 distributes top and bottom also. So remember what I said, it's easier to take the 5th root of something than to square those numbers. So the 5th root of 243, I'm going to look at my chart, is 3. So you have left 3 squared on the top. And then on the bottom, the 5th root of 32 is 2. And then you have 2 squared. So your final answer is going to be 3 squared, which is 9, and 2 squared, which is 4. So it is 9/4. The number 21. Isn't it crazy how this whole big number just gave us something so simple? Kids always think that's kind of crazy. Alright, last one I'm going to do from this section is number 22. So let's go, I'm going to turn to that and do number 22. So I have negative 64 to the 2/3 power. Now there's different ways. You can write this in radical form, or you can try to break down the 64. Let me see. I can rewrite 64. Look at my chart. And 64, I know that's 8 squared, but I think you can write it smaller. 2 to the 6th power. Yep. So 2 to the 6th power is 64. And that's to the 2/3. So I have my staggering exponents, right? So I have negative 2 to the 6 over 1 times 2/3, right? So you have that face. These are your eyes. Here's your nose, and here's your mouth. Anytime you have those staggering exponents, you multiply. So I get -2 here. 6 times 2 is 12. 3 times 1 is 3. And then 12 divided by 3 is 4. So you have -2 to the 4th power is going to give you positive 16. Just think about it, because you have -2 times -2, which is positive 4. If you have another set of -2 times -2, you get positive 4. So 4 times 4 is positive 16. All right, that concludes the first half of your review. We'll go ahead and turn to the back.